All right, let's begin with the class. In the last class, we discussed exponential equations, two types of exponential equations, and we solved examples as well. And today, inshallah, we are going to continue with logarithms. And we also took an introduction. We took an introduction of logarithms as to how to express from how to convert from index form to log form. I guess there's some, yes, it's getting a bit slow. So, okay. So we learned a bit of recap of what we have understood in the last class. So log form से index form से log form में करना सीखा था, from index form to log form, and from log form to index form. And this was mainly what we discussed. Log of answer with a base is equals to power. And keeping this in mind, we learned how to convert from index form to log form and how to convert from log form to index form. And this is something really important because this is something that you are going to see in future as well, inshallah, in integration questions and differential equations questions. This is something really important. Then one thing that I told you was that for log of y with the base of a to be defined, the base a has to be greater than 0 and the base can never be equal to 1. मैंने कहा था ये दो सेपरेट बातें हैं, लेकिन ये ए बेस से ही रिलेटेड है, तो मैंने एक ही लाइन में लिखी थी, ए इज ग्रेटर देन 0 एंड ए इज नॉट इक्वल टू 1 एंड दिस वाई हैज टू बी ग्रेटर देन 0. मतलब आंसर जो है, दिस आंसर हैज टू बी greater than 0. The base has to be positive, the answer has to be positive, and the base can take all the positive values except 1. Then we discussed the rule log of a with the base of a equals 1. If the base and the answer both are same, this means the power is 1. So that is why log of 100 with the base of 100 is 1. Log of 50 with the base of 50 is 1. Then we understood that if the base is a and if we get 1 as the final answer, if the base is a and if we get 1 as the final answer, then this means the power would have been 0. So log of 1 with a base of 1000 is 0. Log of 1 with a base of 200 is 0. No matter what the base is, if the answer is 1, then this means that the power is 0. Then we solved few basic logarithmic equations by first expressing the equation from log form to index form, and then we found the values of x. In example number 3, we got two values of x, x2 and x negative 2, but then we rejected negative 2. Why? Because negative 2 was not defining the original equation. So whenever we are solving logarithmic equations, we always need to ensure that we verify the answers by substituting in the original equation and reject any answers which causes the logarithm to be undefined. कोई भी ऐसा आंसर जो लॉग को डिफाइन नहीं कर पा रहा, उसे हमें रिजेक्ट करना पड़ेगा. सही है? तो ऐसा नहीं है कि अंधाधुन हम कोई भी आंसर दे दें. We cannot just give answers like that. We have to check which answers are valid and which are not, right? Okay, moving forward, common logarithm and natural logarithm. You were told that all the logs have a certain base. Log without a base is not defined. Every logarithm has a certain base. So, and the base can be any number, because we know that if the base is a, the base has to be positive and the base should not be equal to 1. This means the base can be 2, the base can be 3, the base can be 4, the base can be any number. But if the base is 10, then that particular logarithm is known as common logarithm. यहाँ ये बात लिखी हुई है. कौन सा logarithm common logarithm होता है? The common logarithm is the logarithm with a base of 10. ऐसा logarithm जिसकी base 10 हो, that logarithm is known as common logarithm. Log with a base of 10 is also called LG. अब जिसने log जिंदगी में पहली दफा पढ़ा है, they have been told that whenever we are taking log, we always have to write the base. We always have to write the base. जब भी हम log लेंगे तो हमें base लिखनी पड़ेगी. log लेंगे तो हमें base लिखनी पड़ेगी. लेकिन जब बेस 10 हो, जब बेस 10 हो, तो आई कैन जस्ट राइट LG. So if the examiner is using LG, then you would be knowing by default that this LG means log with a base of 10. Log with a base of 10 is called common logarithm. अच्छा, अभी एक बात, one thing that I need to tell you is, in calculator the key with log written is basically LG. अब यहाँ examiner जब सवाल देता है, when the questions are given by the examiner uses LG. But if we check out our calculators, remember in the last class I told you to check out your calculators, and in the calculator we have one of the options in which if we press the key, we are told to give the base, to enter the base and the answer both. Now there's another log as well, which is just simply log. Find out in the calculator and let me know if you have been able to find. One of the options in the calculator is this one, in which we are told to enter the base as well as we are told to enter the answer. And one log is only log written. Just check out if you can see log. अब this log is basically LG. तो examiner जब सवाल देगा, so in the questions the examiner will be using LG. So if we are using calculator to solve such questions, we are going to use this log key. This log key in the calculator is basically LG. Calculator में LG नहीं लिखा हुआ, calculator में log लिखा हुआ है, but examiner will be using LG. तो आप समझ जाएं कि whenever LG is being involved, then this log key has to be used. देखिए इसकी मिसाल देखते हैं. We all know that log of 10 with a base of 10 will be equal to 1. So this means that if that log key is pressed in the calculator and if we write log 10, LG 10 1 होगा. LG 10 equals to 1. Log with a base of 10 is known as common logarithm and we write it as LG. So log of 10 with a base of 10 is 1. So we can also say that LG 10 equals 1. But calculator mein there is no LG. There is just log. So if you are going to type log 10, just check out that you will be getting 1 as your final answer. So log of 10 is 1. So that log in your calculator is basically log with a base of 10. Always remember this. And this log is known as common logarithm. I have already written over here as well. In calculator, the key with log written is basically LG. Okay, and then LGY equals X. Now this is the log form. And if we have to convert into index form, then we first need to know that LG is basically log with a base of 10. So log LGY means log of y with a base of 10 is equals to X. And if we are to convert from log form to index form, then we will write like this. Y is equals to 10 to the power of X. Y is equals to 10 to the power of X. Why? Because the base is 10, the power is X. So base is 10, the power is X, and the answer is Y. So 10 power X equals Y, right? So this is the common logarithm. These common logarithms are usually used for calculation purposes, as I will be telling in the examples as well. मुझे बताएं यहाँ तक सबको clear है? Is it clear to everyone till here? कोई मसला तो नहीं है? कुछ पूछना तो नहीं चाह रहे यहाँ तक? I already tried to ensure that I repeat multiple times, so I don't think there has to be much problem. But एक थोड़ा सा interactive रहना चाहिए, पता चलना चाहिए कि बच्चे जाग रहे हैं, सो नहीं रहे. Natural logarithm क्या होता है भाई? Natural क्या होता है? Log with a base of 10 is known as common logarithm. Log with a base of e is known as natural logarithm. Log with a base of 10 को हम LG कहते हैं. Log to the base of 10 is written as LG. Log to the base of e is written as ln. Whenever you see ln involved in the exam questions, for run you need to recall that this ln is basically log with a base of e. There are so many logs, there can be so many bases, but there are two types of bases. दो किस्म के logs ऐसे होते हैं जिसके नाम हम जानते हैं. So if the base is 10, the name is a common logarithm. If the base is e, we call it a natural logarithm. The natural logarithm is ln. The natural logarithm is the logarithm with the base of e. So log with the base of e is called ln. अच्छा 10 एक number था ना, 10 was a number. Similarly, e is also a number. The question is, what is the value of e? What is the value of e? So if you are going to type in the calculator, just check out the function. In the last row, uh, besides equals to sign, there is answer, and besides answer key, there is another key. Just if you're pressing that key with shift, then you'll be seeing pi, and if you're pressing that key with alpha, then you will see e. Achha, there is another function as well, e with a certain power. तो वो अगर आप सिर्फ अल्फा ई प्रेस करते, then you will get to know that value is 2.71828. And if you're going to press this key, e with a certain power, then you're going to write e to the power of 1. E to the power of 1. E to the power of 1 will be 2.71828. So just like if the base is 10, we call it LG. So if the base is E, that is, if the base is 2.71828 something something, जिसको हम E कह रहे हैं, then in that case, that will be a natural logarithm and we call it ln. बस मतलब बताने का मकसद ये है कि जैसे 10 एक वैल्यू है, वैसे E also has a certain value and that value is this. फिर मैंने कहा, if let's suppose if you see ln y is equals to x and this is log form and you have to convert into index form, then you first need to recall that this ln means log with a base of e. So log of y with a base of e equals x. Then if you need to convert from log form to index form, then the base is e, the power is x, so it's e power x, and this will be equal to y. So e power x will be equal to y. So we can convert ln y equals to x in the form of y equals to e power x, as we know that ln means log with a base of e. I guess it's very clear. I don't think there's anything which is confusing over here. और कुछ खास हमने इसमें लिखा हुआ भी नहीं है. मैं if I write ln1, no sorry, ln e. What is ln e? So ln e is 1. LG10 is 1. Because LG10 means log of 10 with a base of 10. So if the base and the answer are same, the power is 1. So LG10 is 1. Similarly, ln e is 1. How? Because ln means log with a base of e. So log of e with the base of e, the base and answer are same. So equals power, power will be 1. So ln e will always be equal to 1. As a matter of fact, ln1 is 0. LG1 is also 0. There are two rules that we studied, right? No matter what the base is, no matter what the base is, if over here we see a 1, then the answer is a 0. So log of 1 with the base of a is 0. So log of 1 with the base of e is also 0. Log of 1 with the base of 10 is also 0. So ln1 and lg1 both mean 0. Similarly, lg10 means 1. Ln e means also 1. So you can just write this in your notes. Rest, I think, is pretty much clear to all of you. Acknowledge. Is it clear? All right, great. Moving forward, let's look at few examples. Examples की तरफ आ जाते हैं. First example, solve the equation 5 power x is equals to 23. If you recall, I told you in the last class that if we are solving an exponential equation, अगर हम एक exponential equation solve कर रहे हैं, and if that exponential equation is of the simplest form in which this number is convertible. Remember, if I told you if a power x equals b, and if b can be written as a power n, then in such case x will be equal to n. But if b is not convertible to a power n, then in that case we have to use logarithms. It was written in the notes and I told you that I will be covering that later. Just wanted to show you. 5 power x equals 23 and we have to find the value of x and we'll use logarithms to, and this is to be solved later. Now it is the right time that we can solve it, right? So 5 power x is equals to 23. How can we solve it? Now there are two methods to solve it, right? There are two methods to solve this particular type of equation. 5 power x is equals to 23. Now we see that the base is 5, the power is x, and the answer is 23. The method number 1 says take LG or ln on both sides. When we are solving, we can take any kind of log on both the sides. When there's a square, we take a square root on both sides. When there's a square root, we do squaring on both sides. Similarly, when there is an exponential equation in which log needs to be taken, what we can do is we can take any log on both sides. Log with the base of 10 on both the sides, log with the base of 5 on both the sides. We can take any kind of log. But you know which kinds of log are better to take? It's better to take common or natural log. Why? Why is it better to take common or natural log? Because in our calculators, we have two keys present. LG with a log and ln. कैलकुलेटर में हमारे पास दो कीज है ना, एक log, एक ln. There are two keys. One is log, one is ln. Now, when these two keys are present in a calculator, so it's better to take these kinds of log because it is quicker. We will not have to enter the base in such cases. तो इसीलिए यहाँ पर पहला मेथड लिखा हुआ है कि we can take any kind of log, like log with any particular base, but it's better to take LG and ln. That is why method number 1 instructs you to take LG or ln on both sides. So how to do this? Let's check it out. Both the examples using method number 1 and then both the examples using method number 2. So method number 1, take LG or ln on both the sides. So if we are taking LG, the question is, so is it better to take LG or ln? So listen, if the base is E, then it is better to take ln. Although we can take LG as well, but it is faster and quicker to take ln. Why? I will be solving and telling you later. But if the base is 5 or base is any other number other than E, it's equally like it does not create any difference if you take LG or ln. You can take LG or ln on both the sides. So just to a touch of LG once and touch of ln once, I'm taking LG on both the sides in example number 1, although I could have taken ln as well. So LG 5 power x is equals to LG 23. हालांकि मैं ln भी ले सकता था, but over here I have taken LG. So LG 5 power x equals LG 23. Now there are different laws of logarithm that I am going to tell you sooner inshallah. अभी थोड़ी देर में बताने वाला हूँ. So one of the laws is a power law. Power law ये कहता है, power law tells us that if there is a power and if you have taken log on both the sides, then this power comes down at the back of the log. जो log हमने लिया है, ये power उसके पीछे आ जाती है. This power comes at the back. So this is known as the power law. जब LG या ln on both sides लेंगे, कोई भी log लेंगे, so the power will come down. So we are going to write like this: x LG5 is equals to LG23. So from here, x will be equal to LG23 upon LG5. LG23 upon LG5. So if we are going to calculate it, LG23 upon LG5. Calculator mein there is no LG key, there is log, remember, right? So log 23 upon log 5, your answer will be 1.9482. What are the accuracy guidelines? Remember, from AS I have been telling, workings are to be in 5 significant figures and the final answer has to be in 3 significant figures. So 1.9482, and then we are going to round it off to 1.95. So जब 3SF में 1.95 ही देना था, why have we written 1.9482? क्यों लिखा है हमने 1.9482? क्यों लिखा है? इसलिए लिखा है because let's suppose if this particular answer is to be used in subsequent parts, then we will not be using 1.95. We are going to use 1.948. So this is an approximately equal to sign. Even if you make equals to sign, it's perfectly fine, not a big deal. But बहरहाल मेरी आदत है, as per practice, I'm writing this. So x is approximately equals to 1.95. So this is example number 1 using method number 1. So यही हम काम करते हैं. Let's draw a margin over here and do example 2 use this method. सही है जी. फिर यहाँ भी मार्जिन बना लेंगे तो 2 पोर्शंस हो जाएंगे. ओके, परफेक्ट. चलें. If we look at method number 2, sorry, method number 1, example number 2. Solve the equation e power x is equals to 20. So what we have to do? We have to take LG or ln on both the sides. But I've already instructed you that if the base is e, then it is better to take ln. So let's take ln on both the sides. Although it's not essential, you could have taken LG as well, but it's simpler to take ln. Why? You'll get to know sooner, inshallah. Let me tell you quickly. जल्दी से बता देता हूँ. ln e power x is equals to ln 20. As per the power law, x will come at the back. X ln e is equals to ln 20. Now we all know that ln e equals 1. Because ln e means log of e with a base of e. So if this is 1, then the answer of x will be ln 20. So this will be simpler and quicker. अगर मैं LG लेता, LG लिया हुआ होता, तो LGE will have to be calculated and then we'll have to divide LGE as well. But as ln E is 1, so we don't have to divide. So you'll save 20 seconds of your time, right? Not much, but you'll save 20 seconds of your time. And it's preferred that you take ln over here. So if I am going to give the answer, it is 2.9957. 2.9957. And then from here, your answer to 3 significant figures, your answer in 3 significant figures will be 3.00. 3.00. This is your final answer. 2.9957, 3SF may we are going to round this digit 9. After this 9 is a 5, so this 9 will become 10. So 99 will become 100 and 00 will come over here and 2 will become 3. So 3.00. So if you are going to write just 3, this means that you got an integer answer. But 3.00 means that you have not got an integer answer. Rather, you got some decimal value which has been rounded off and has become 3.00. So we have understood, we have solved both the examples using method number 1. Are we all clear? And are we all on the same page? सबको समझ में आ गई ये बात? Please acknowledge. So whenever we are solving an exponential equation and the other side is not convertible to the same base, then we take LG or ln on both the sides. This is one of the methods. So can you explain why log won't work for the second one? Log will work. Log will work. If you're taking LG on both the sides, it will work. But what we'll have to do is LG20 divided by LGE. We'll also have to calculate LGE. You'll get the same answer. Just try it out. Log of 20 divided by log of E. Yes, I'm getting the same answer, 2.995732274. But the problem is I will have to calculate LGE as well, and then I will have to divide LGE. I'll have to divide LG20 by LGE. But if we are taking ln on both the sides, so ln E is 1. So some of our seconds are saved, and we can quickly calculate ln 20. कुछ डिवाइड करने की जरूरत नहीं पड़ी, डायरेक्ट हमने ln 20 जो है आंसर के तौर पे पेश कर दिया. यही तो मैं कह रहा हूँ कि LG लेने में कोई मसला नहीं. You can take LG as well, but ln is quicker because LGE is not 1, but ln E is 1. It will be quicker for you to use ln. Have I made my point clear? Have I made myself clear in this regards? Okay, clear. So method number 2, convert to log form. So these two forms, these two examples, we can see that this is index form. So if we are going to solve example number 1, let's convert this index form to log form. लॉग फॉर्म में इसको कन्वर्ट करते हैं. अब आपको पता है दिस इज बेस, दिस इज पावर, दिस इज आंसर, एंड इन लॉग फॉर्म वी नो log of answer with the base equals to power. देखिए एक स्टेप में काम हो गया आपका. यहाँ पर क्या किया, LG लिया, then you use power law, then you divided, and then you got the answer. Over here what you have done is you have just converted from index form to log form. You know that 23 is the answer. You know 5 is the base. So log of 23 with a base of 5 equals to power, and the power is x. So log of 23 with a base of 5 is equals to x. Log of 23 with a base of 5 is equal to x. Now the only thing that you have to do is to pick up your calculator and enter this. That's it. Third अगर जो key है ना, in which there is a block, and here is also a block. Enter 5 over here, enter 23 over here, and you'll get the answer. So let's try it out. Log with a base, log of 23 with a base of 5 is 1.9482. आंसर वही आना है, आंसर में कोई फर्क नहीं पड़ना, and rounded off to 1.95. Okay. Okay, then example number 2, by converting from index form to log form, e power x is equals to 20. What we can do? Log of answer, which is 20, with a base of e equals to power, which is x. And now we know that log with a base of e is known as ln, because it is a natural log. So log base e can be written as ln. So I'm just rewriting it as ln. So ln 20 equals x. So now just pick up your calculator and type ln 20, and you'll get the same answer as you have got previously. 2.9957, which will be rounded off to 3.00. Right? So I have solved both of these exponential equations using 2 methods. I guess both of the methods are pretty much clear to everyone. Just acknowledge if everyone is clear till here. Okay, great. Chale, clear and done. So if it's written as well, everyone is clear. Perfect, 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 perfect. चलो ये हो गया. चले जबरदस्त. चले जी. All right, moving on. Laws of logarithm. Let's move on to understand the laws of logarithm. Now there are three laws of logarithm in A2. Those who have studied additional mathematics in O levels or IGCSE, then there was another law as well, and that was change of base law. But in A2, in P3, there is no change of base law, only three laws we need to understand, right? So the first law is product law. Laws of logarithm, the first law is product law. Now we have to understand one by one. Product law, what does product law says? Product law tells us that if log is applied, log with a certain base is applied on a product, log of x into y with a base of a. And if you're going to open it, then it will convert into log of x with a base of a plus log of y with a base of a. Log of x with a base of a plus log of y with a base of a. So multiplication gets converted into addition. And if we check out quotient law, then log of x upon y with a base of a is converted into log of x with a base of a minus log of y with a base of a. This means over here, both the numbers are in the numerator, right? So we have to add. Multiplication gets converted to addition. And if there's a division, then the numerator with a plus sign and the denominator gets subtracted. So log of x with a base of a minus log of y with a base of a. Now notice one thing, which is very, very important. In addition subtraction form, अच्छा मैं जो बात बताने जा रहा हूँ बड़ी इंपॉर्टेंट है, राइट? फोकस करना, क्योंकि दिस इज अ गेम चेंजर. The conceptual blunders lie, the conceptual blunders takes place just because students are not clear with this. Multiplication division form. Multiply या divide वाली जो form होती है, let me write the whole multiplication. If it's multiplication or division, then log once. If it's addition or subtraction, then log twice. अब इस चीज को थोड़ा सही से समझ लें, right? Concentrate on this. If okay, if log of xy with the base of a, then if we take lgxy, पहले इसको भी समझ लें. अगर lgxy, तो what is lg? lg is basically log with the base of 10. So lgxy gets converted to lgx plus lgy. ln means log with the base of e. ln xy gets converted to ln x plus ln y. So this is the application of product law. Now we also need to know that at times left hand side is given and we need to convert into right hand side. At times right hand side is given and we need to convert into left hand side. So it works both way around, right? दोनों तरफ से ये काम करता है, ऐसा नहीं है कि एक तरफ से काम करेगा. Log of xy with the base of a gets converted to log of x with the base of a plus log of y with the base of a. Multiplication form gets converted to addition form. And if it's an addition form, it gets converted to multiplication form. Multiplication gets converted to addition and addition gets converted to multiplication. But we need to know one thing. In the multiplication form, the log is just once. In the addition form, log is twice. Similarly, division gets converted to subtraction and subtraction gets converted to division. But the division form has log once and the subtraction form has log twice. So multiplication, division, log once. Addition, subtraction, log twice. Why am I emphasizing on this? मैं इस पे क्यों उतना ज्यादा स्ट्रेस कर रहा हूँ? क्या फोकस है? क्यों फोकस कर रहा हूँ उस पे? Check out this note, which is a common blunder by the students. We all know that if we are going to multiply x plus y by 2, then we are going to get 2x plus 2y. If we are going to multiply x plus y by 2, we are going to get 2x plus 2y. But in case of logs, this is not the case. Log with a base of a is not a number like 2 that we multiply it by x and we multiply it by y and we take plus in the and we take a positive sign in the middle. No, it's not like that. Log of x plus y with a base of a cannot be equal to log of x with a base of a plus log of y with a base of a. We cannot do like that. So in log, addition on both the sides is not at all possible, because multiplication gets converted to addition, addition gets converted to multiplication, but addition getting converted to addition is not possible. So log with the base of a will not work like normal number 2. So we cannot just simply multiply. So this is common error number 1, and that is why I have written that this is not equal to this. Okay. Then another common problem. Sir, you have told that addition gets converted to multiplication and multiplication gets converted to addition. So if it's log of x plus y with the base of a, then I can do like this. Log of x with the base of a multiply by log of y with the base of a. But sir has also told you one another thing. In multiplication division form, log has to be once. In addition subtraction form, log has to be twice. Over here, it's an addition form. And the base is this is an addition form and the log is once. X and y are being added and log is seen once. So it is not possible to be converted into multiplication form by taking log twice. No, this is not the law. Sir, we cannot convert log of x plus y with the base of a into this form. Neither can we convert into this form. Then what to do with this? This will remain like this. This will remain like this. अगर कभी किसी सवाल में ऐसा हो जाए तो इसको ऐसे ही छोड़ देना है. It has to be kept like this only. So always remember that addition cannot get converted to addition. Addition can get converted to multiplication using product law, but in addition form there has to be log twice, because in addition form there is log once. Then you just try to recall. The sir has explicitly mentioned, specifically mentioned and emphasized that in addition form log is twice. In multiplication form log is once. Similarly, if we talk about quotient law, then log of x minus y with a base of a cannot be converted to negative. Subtraction cannot get converted to subtraction. It does not work like normal multiplication, as I've already told in addition as well. Similarly, subtraction getting converted to division, but over here it's not possible, because in subtraction form log is once, in division form log is twice. So this is not possible. In division form the log has to be once, in subtraction form the log has to be twice. So this is also not the application of quotient law. This is not the application of quotient law. Similarly, this is also not the application of product law. And in note number 1, log normal multiplication does not take place using logs. And the third law is a power law that I've already implemented before, but here also I need to emphasize something. Log of x with a base of a, and this power r is on this x. Log of x with the base of a. A is the base and x is the answer. If the power r is on the answer x, मैंने सिखाया था ना, log of answer with a particular base, right? But now the power is only on this answer, not on the whole log. So if log of x with the base of a and there is a power r at the top of x, just being applied on x, not whole bracket. then this r gets multiplied by the log. It comes down. It becomes r times log of x with the base of a. R comes down. It becomes r times log of x with the base of a. ये आपका पावर लॉ की एप्लीकेशन हो जाएगी. नोट फॉर्म की अगर हम बात करें तो आई हैव रिटन दैट log of x with the base of a within the brackets and there is a power r on whole of it including the log. Even the log is within the brackets. Then the power law won't work. Now this is not possible that r gets multiplied by the log. This is not possible. This is wrong. This is a common blunder. We can never do like this. सिर्फ और सिर्फ x पे पावर होनी चाहिए. पूरे log पर पावर r नहीं हो सकती. नहीं हो सकती. It only has to be on this x. Then only can we say that power law is being applied. But if it's on the entire log, then power law won't work. It's not true. This thing is not true. That's why I've written not equals to. But in such cases, when something like this is involved, then we have to use appropriate substitution in such cases. We have to use appropriate substitution in such cases. Let log of x with the base of a equals b, let's suppose, and then we will solve an equation and then we'll do something. But this is something that I'm going to tell you with examples in future as well. तो मेरे मुताबिक मैंने समझा दिए तीनों laws. I think I've explained all three laws. If there's something that is confusing you, if there's something that you think is troubling you, you can definitely ask. Yes, these laws are applicable with LG, LN. LG and LN are also logs. LN is log base E and LG is log base 10. They are also logs. So if these laws are applicable on logarithm, then these laws are applicable on LN, LN and LG as well. चलें जी, ये बात हमें क्लियर हो गई है, समझ आ गया है, कोई ऐसा मसला नहीं है. ये बात आप लोगों ने लिख ली होगी. Multiplication, division, log once, addition, subtraction, log twice, right? Moving on towards few examples. I guess 2 pages are left. Yes, if we are going to solve these examples, then inshallah, ultimately we are going to be able to solve all the past papers, inshallah. So let's start. In this topic, we have been focusing on 2 types of equations, exponential equations, and there are 2 types of exponential equations that we studied in the last class. The terms are being multiplied or divided. Then we make the basis same. And we use the laws of indices and we equate the powers. And in type number 2 of exponential equations, if there is addition, subtraction being involved, then we use appropriate substitution. So exponential equations, 2 types. Logarithmic equations, 3 laws. If you see the variable in power, then you'll be able to judge that it is an exponential equation. Exponential equation, type 1, multiplication division only. Type 2, addition subtraction, in which we have to use appropriate substitution. If we see logarithmic equation, sir, हमें कैसे पता चलेगा कि logarithmic equation है? How will we come to know that the equation is a logarithmic equation or is it an exponential equation? So if there's a variable in the power, it is an exponential equation and it could be dealt with using 2 of the types that we have studied. Or अगर log involved है, if ln is involved, lg is involved, or any other log is involved, then that particular equation is a logarithmic equation. And one instruction has already been given to you, that whenever the equation is a logarithmic equation, and if we get multiple answers, then we have to verify the answers by substituting in the original equation and reject any answers that causes the logarithm to be undefined. So this type of equation is a logarithmic equation. Logarithmic equation देखेंगे, we can recall that there are 3 laws of logarithm. Now, how to apply this? Now I have 2 methods to deal with this type of equation. Let's look at method number 1 first. We can see ln of 1 plus x square. We can see ln x, 2 ln x, 1 plus 2 ln x. What we can do is, the first thing is, we can use power law on 2 ln x and we can make it ln x square. And then we can also do one thing. We can shift ln x square to left hand side. So this is what I'm going to do now. ln 1 plus x square minus ln x whole square. मैंने 2 steps एक साथ कर लिए, right? 2 steps together over here is equals to 1. The first step, 2 shifted to the power, 2 became the power of x using power law, ln x square, and then shifting ln x square to the left side. Now there's subtraction involved and there is log twice. This means quotient law is applicable. If there's a subtraction, it can get converted to division. So we are going to write ln 1 plus x square divided by x square is equal to 1. Then what we can do? अच्छा, अब हमारे पास ये मामला आ गया, right? This is the step that we have got. Now we have to find the value of x. Now, after this step, we have to convert from log form to index form. We have to convert from log form to index form. Convert into index form. So we already know how to convert from log form to index form. Now this ln is what? This is log with a base of e. So we know that the base is e. This 1 is the power, and 1 plus x square upon x square is the answer. So if I am going to write this in index form, then I'll say base is e, the power is 1. So this is e base with the power of 1 is equals to answer, which is 1 plus x square divided by x square. Then what we can do is we can cross multiply ex square is equals to 1 plus x square. Then ex square minus x square, and x square can be taken as common. So e minus 1 x square is equals to 1. I've saved one of the steps. X square shifted to left side. Then ex square minus x square, we took x square as common. So e minus 1 x square equals 1. And from here we are going to get, x square is equals to 1 upon e minus 1. And then we can say x is equals to square root of 1 upon e minus 1. We also need to know that whenever we are removing even power, we will take plus and minus both. जब भी even power हटेगी, तो plus and minus दोनों आएंगे. So whenever even power is being removed, we have to take square root, we have to take plus minus on the other side. But over here, I'm not taking plus minus. Why? Because I know that if I'm going to take a negative number over here, if x is a negative number, then the original log won't be defined. X square में तो कोई फर्क नहीं पड़ेगा. This will be defined. But if negative value gets substituted over here, then this x has to be positive. Log of y with a base of a. This y has to be positive. So in place of y over here, we have x. So x has to be positive. So I knew that negative value would not be defining the original logarithm. That is why I have taken only square root with a positive sign and I've ignored the negative possibility. So from here, I can use my calculator and I will give the answer. X is equals to square root of 1 upon e minus 1, square root of 1 upon e minus 1. And the answer that I'm going to get is 0.76 287. Let me rewrite. X is equals to 0.76287. And then we are going to round it off. So this is going to be 0.763. ये मेरा final answer हो जाएगा. X will be equals to 0.763. ये मेरा method number 1 हो गया जनाब. Subtraction gets converted to division, and then finally we got x equals to 0.763. This is method number 1. मुझे बताएं method number 1 सबको clear है? किसी को method number 1 में कोई doubt? Any confusions in method number 1? Please acknowledge. I have a question. Definitely, Manam. You can ask the question on mic. पूछो क्या मसला है? I am confused at how it gets converted to E. The green part. Okay. I don't get the first 3 steps. देखिए बात सुने. 1, 2 और 3. फर्स्ट 3 स्टेप्स तो ये हो गए. सही है. ये नहीं समझ आ रहा. देखिए मैं आपको बताता हूँ. फोकस करें थोड़ा सा. सबसे पहले आपने क्या किया? सबसे पहले मैं स्टेप को बढ़ा देता हूँ. सही है. मैं एक और स्टेप बीच में कर लेता हूँ. ln 1 plus x square is equals to 1 plus ln x whole square. This is the first step. This 2 becomes the power of x. 2 यहां से हटा, यहां आ गया. ln x square बन गया. This is the application of power law. Tell me, is it clear till here? यहां तक clear है? उसके बाद after that we know that if the two logs, अच्छा Alia, you also have to acknowledge, right? If the two logs are being added or subtracted, then in that case, बल्कि माइक पे आ जाओ ना आलिया, माइक पे आ जाओ, फिर मैं 1 by 1 माइक पे लेता हूँ. माइक खोलो आलिया, ताकि मुझे एक्नॉलेजमेंट साथ साथ मिलती रहे.
That's clear, sir.
अब देखें, बात सुने. फर्स्ट स्टेप ये हो गया, पावर लॉ एप्लीकेशन हो गई. देन व्हाट वी आर गोइंग टू डू इज ln x square will be shifted to left side. So we'll get ln 1 plus x square minus ln x square equals 1. Is it clear till here? यहाँ तक भी सही है?
जी sir.
अच्छा अब देखिए, if there's a subtraction involved and there's log twice, ln over here as well, ln over here as well, and there's a subtraction sign in the middle. So this means we know that ln x minus ln y is equals to ln x over y. This gets converted to this and this gets converted to this. This is quotient law that I have taught above. तो इस चीज को मद्देनजर रखते हुए x की जगह पे 1 plus x square है, और in place of y there is x square. In place of x there is 1 plus x square. In place of y there is x square. So if we are going to subtract, then we are going to divide. So ln 1 plus x square divided by x square equals to 1. So first 2 steps were not clear. Is the second step also clear now?
So this is the quotient law you have used in the second step?
Yes. I've used the quotient law. This is
Okay, sir.
quotient law. Yes, this is the quotient law that I've used. Okay. Then once I've used the quotient law, I have got this log form, but I cannot solve it further. So what is the way out? Now comes Manam into action. Manam, what is the way out? We have to convert this log form to index form. So let's look back at what we studied in the last class. Log of answer with a particular base is equals to power. So this particular number is known as answer. This is known as base. and after equals to comes power, right? Now, if we are converting from log form to index form, what we will do? We'll write the base. At the top of it, we write the power and we equate it to the answer. So we are going to write like this: base, power, and after equals to answer. So conversion from log form to index form. Now check it out. यहां से देखें, ln मतलब log की base क्या है? E. ln means log to the base of E. So E is the base. E is the base. And this one is the power. And 1 plus x square upon x square is the answer. So e to the power of 1 is equals to 1 plus x square upon x square. Right? E is the base, 1 is the power. So e to the power of 1 and equals to answer. So 1 plus x square upon x square is the answer. Base, power, answer. Great. So you have understood it now, right? Okay, great. So then after that we cross multiply, then we make x the subject and we got the answer. Are we all clear with method number 1 now? Acknowledge कर दें आप थोड़ा सा. Okay, moving on towards method number 2. Method number 2 क्या कह रहा है हमें? Method number 2 is, now look, what is method number 2? Method number 2 says rewrite 1 as ln e and then use product law. So I'm solving it over here. ln 1 plus x square is equals to 1 is equals to ln e plus ln x square. Application of power law on 2 ln x. So 2 ln x gets converted to ln x square. 2 ln x gets converted to ln x square. 1 gets converted to ln e, because we know that if there's, let's suppose if there's lg throughout, then we are going to substitute lg10 in place of 1. lg10 is equals to 1. ln e is equals to 1. If there's log base 5 throughout, then in place of 1, we are going to take log of 5 with a base of 5, because that will be equal to 1 in that case. So whatever the question is, usually we see LG and LN in P3 questions. So if there is LG, then in place of 1, we write LG10. If there is LN, if there is LN, then we write LN E in place of 1. And if there is log base 5, then we write log of 5 with a base of 5 in place of 1. So over here it's ln, over here and here. So we convert 1 to ln e. Now check out what I'm going to do. Now ln e plus ln x square. 2 logs are being added. So what I will do, I will use product law. I will use product law. I'm going to use product law. So now let's see, ln 1 plus x square is equals to ln ex square. Addition gets converted to multiplication. In addition form, log is twice. In multiplication form, log is once. So we have written ln and we have multiplied e by x square. So it becomes ln ex square. Ln ex square. Ln 1 plus x square is equals to ln ex square. Now what will happen? Now we can compare using this rule. Now just take a look at this note. If log of m with a base of a is equals to log of n with a base of a, then this means m is equals to n. Similarly, as we saw previously, if a power x is equals to a power n, bases are same, then definitely the powers are also same. X is equals to n. X equals to n. Similarly, if log of m with a base of a is equals to log of n with a base of a, at both the sides there is log base a, then definitely m and n has to be equal, then only both the sides will be equal. So using the application of this, ln 1 plus x square equals ln ex square. So using this note, this will be equal to this. They will be equal. So this means 1 plus x square is equals to ex square, and then the process will continue. 1 plus x square equals ex square, and then the process will continue and we'll get 0.763 as our final answer. After this step, the process is same. So no need to rewrite that process again. Just there's a difference in the starting working. There's a initial steps are different. After that, the last few steps are same. So method number 1 used quotient law. Method 2 used product law. But for that, and in method number 1, we have to use quotient law and then we have to convert from log form to index form. In method number 2, in place of 1, we have written ln e. Then we use product law and then we equate and then we get the same answer. I guess I've made myself clear with both the examples. With both the methods. For example, this example is just similar to the past paper question because in past paper question we see similar questions. So I hope I have made myself clear. Please acknowledge if everyone is clear with this. Okay, clear and done. Have you written as well? If you are done, please write clear and done. All right, so you are done, right? Moving forward, this node is also clear. Another example we have, solve the equation log of x with a base of 3 whole square minus 5 times log of x with a base of 3 plus 6 equals to 0. So if you are going to solve it, I've already told before that if there is a power on the entire log, if there's a power only on x, then power law can be used. But if there are brackets on the entire log and there's power on the entire log, then the power law is not applicable. So in such cases, we use appropriate substitution. So I've taken one example like that as well. What we can do is let log of x with a base of 3 is equals to a. We can call it a, b, anything we wish. So this means log of x to the base of 3 is a. So this will become a square. This will become 5a. This is 6 equals to 0. Then if you're going to middle term break, then it will become a square minus 6a. No, not the correct factors. Minus 3a minus 2a, because minus 3a minus 2a multiplied will give us 6, positive 6a square. Yes, so we need positive 6. So a is taken as common. A minus 3 minus 2 taken as common. A minus 3 equals to 0. Then a minus 3 taken as common. And we'll get a minus 2 equals 0. We'll get two values, a equals 3 or a equals 2. If a is equals to 3, but these are not the final answers because we have used substitution. So we have to use substitution again as well. So if a equals 3, if a is equals to 3, then this means log of x with a base of 3 is equals to 3. And another possibility, log of x with a base of 3 is equals to 2. Can someone tell me what the answers of x will be? What will this answer be? Log of x with a base of 3 equals 3. How will I get the value of x? Yes, it's 27. देखिए यहाँ पर 3 नहीं है कि log of 3 with a base of 3 will become 1. This is log form. We have to convert it into index form. So this is base, this is power, and this is the answer. This is the base, this is the power, and x is the answer. So x is equals to 3 to the power of 3. So x is equals to 27. Another possibility, x is equals to 3 to the power of 2. 3 is the base, 2 is the power, so 3 power 2, and the answer will be x. X is equals to x is equals to 3 square, which is 9. So we have got two answers, x equals 27 or x equals 9. Right? Have I made myself clear? Any confusion still here? Please let me know. Once you are done, write clear and done. If there's any confusion, do let me know. Moving forward, solve the equation. Example, this has been solved. Then come solve the following equations and inequalities. Right? So first two examples of inequalities and third example is of solving an equation. Now, what kind of an equation is this? This is an exponential inequality, right? Just like if there is exponential equation. So this is an exponential inequality because there's variable in the power and there's inequality involved. So what we are going to do is, we have already seen how to solve an exponential equation. Either we take LG or ln on both the sides, or we convert from log form to index form. Although over here as well, we can convert from log form to index form, but at times students get confused with the inequality sign. So it is better that we take LG or ln on both the sides. And there's another reason behind that. Because let's suppose if it is 0.2 power x less than 0.5. I'll solve this as well. First, let's solve example number 1. So if we take LG on both the sides, LG 2 power x is less than LG 5. Then using the power law, it will become x LG2 less than LG5, and x will be less than LG5 upon LG2. And now from here we can calculate LG5 upon LG2. It's 2.3219, right? So x is less than 2.3219, and we can round it off. X is less than 2.32. Correct to 3 significant figures. This is going to be our final answer. Now, if I take another example, always remember that if log is applied on a number that lies between 0 and 1, if log applies on a number, if log is applied on a particular value, and if that value lies between 0 and 1, then log of that value will be negative. Log of a negative number does not exist. But if log is applied on a value and that value lies between 0 and 1, then the answer of that log will be negative. Just check it out. If you try to find log 0.5 or ln 0.5, you'll get a negative number. ln 0.5 is minus 0.69314718006. So log applied on a value and that value lying between 0 and 1, the answer will be negative. So keeping that in mind, if we adopt the same practice over here, taking LG on both the sides, then using the power law, x LG 0.2 is less than LG 0.5. Now over here, the inequality sign will get reversed. You know why? Why will the inequality sign gets reversed? If someone is directly dividing LG 0.5 by LG 0.2, that person will never come to know that there was some negativity involved and the inequality sign has to be reversed. So always remember that if the numbers are between 0 and 1, and if we are applying LG or ln or any kind of log on that, log with a certain base, any base, log with any base, if applied on a value, the answer will be negative if that value lies between 0 and 1. So if let's suppose LG 0.2 is negative. So if x, the coefficient of x is negative, and if we try to make it positive, the inequality sign will get reversed. So even if someone is dividing directly, then he or she must know this inequality sign has to be reversed. So there are chances of error over here. So let's suppose if someone does not divide directly, if we do all the steps, then calculate log of 0.2. LG 0.2 is what? Minus 0.69897. And this is less than LG 0.5, which is minus 0.30103. I'm working in 5 significant figures. Now we know that there is negativity involved with x. Now that we have seen the negativity, now we know that if we are going to remove the negative signs and if we are going to multiply the entire inequality by the negative sign, the inequality sign will get reversed. Now everyone will say that yes, sir, now it's perfectly fine to reverse the inequality sign. So if we know that these numbers are between 0 and 1, if we have seen that these numbers are between 0 and 1, then we need to recall that log, LG, or any kind of log being applied on these numbers will give us a negative value. And if we are going to divide, although the negative signs will get cancelled, but because there was originally negativity involved with the variable, and that negativity is being cancelled, or we say negativity is being removed by sending it to other side, then in that case the inequality sign has to be reversed. So even if we are going to omit this step, and if we are sending LG 0.2 to that side, we need to know that both of these values will be negative, and therefore the inequality sign will get reversed. So if now you divide LG 0.5, LG 0.2 by LG 0.5, and reverse the inequality sign, then you'll get the answer, and the answer will be x is greater than 0.43068. So from here, the answer will be x is greater than 0.431. So it is recommended that if you are solving inequalities, if you are solving exponential equations, then you can use method 1 or method 2 by taking LG or ln on both the sides, or converting into log form, as we have studied before, as we have already understood. But over here in inequalities, it is better, it is preferred that you take LG or ln on both the sides, because if you are going to convert directly into log form, over here you can do like this: log of 5 with a base of 2, and x is less than this. X is less than log of y with a base of 2. Someone could have written like this. But there is confusions of inequalities and students tend to make mistakes. So I would suggest, and another reason I've already quoted as well, that if the values are not between 0 and 1, then it's perfectly fine. But if the values are between 0 and 1, then because of negativity being involved, the inequality sign will get reversed. So this example and this particular example number 1, we have solved both, and we have now understood, and we have locked that whenever we are solving exponential inequalities, we are going to take LG or ln on both sides, rather than converting directly from from index form to log form, because this particular option that we are opting for is more convenient for us, and it's safe as well. So are you all clear with what I've taught up till now? Any confusions? Anything that you need to ask? Okay, actually, I'm extending the class because just 2 more examples are left, and then the explanation of logs will be ended up, right? So I just want to end the explanation today. Okay, moving on towards the second example. 3 multiplied by 2 power 3x minus 1 less than 5. Now again, to solve this, there are multiple possibilities. Firstly, shifting 3 to that side. Let's suppose 2 power 3x minus 1 is less than 5 over 3. Now, what is the next step? Now, there could be multiple methods. One of the methods is we can take LG or ln on both the sides. But you know what? I'll be teaching you a better method. I'll teach you both the methods over here, and you'll judge which one is better. It is better to split the powers. If you remember laws of indices, 2 power 3x to the power of 2 power 3x minus 1 means 2 power 3x multiplied by 2 power minus 1, or we can say 2 power 3x divided by 2 power 1 is less than 5 over 3. Now also you know that 2 power 3x means 2 power 3 whole power x, and 2 power minus 1 means upon 2 less than 5 upon 3. Now 2 power 3 is basically 8, and this 2 will be cross multiplied. So this means 8 power x is less than 10 over 3. 2 cube is 8. 8 power x is 10 upon 3. Now it's more convenient to solve it by taking LG or ln on both the sides. So x LG 8 is less than LG 10 over 3. We'll take LG on both the sides like this. LG 8 power x is less than LG 10 over 3. Then x LG 8 is less than LG 10 over 3. And then we can divide x is less than LG 10 over 3 divided by LG 8. From here we are going to get the answer. And the answer is x is less than 0.57899. X is less than 0.579. This will be our final answer correct to 3 significant figures. It's 0.579. Right? So, although another way is also possible, एक और method हो सकता था. क्या हो सकता था भाई? Someone could have taken log directly from here. So LG 2 power 3x minus 1 is less than LG 5 over 3. फिर आप क्या करते? 3x minus 1 will come down using power law. 3x minus 1 into LG2 is less than LG 5 over 3. Then what you will do? You will multiply 3x by LG2 and you will multiply minus 1 by LG2 as well. This will become 3LG2 times x minus LG2 is less than LG 5 over 3. And then you will add LG2 to LG 5 over 3 and then you'll divide 3 LG2 and then you'll get the x answer. Minus LG2 will be shifted to right hand side and then 3 LG2 will also be divided. So LG 5 upon 3 plus LG2 divided by 3 LG2. LG minus LG2 को वहां शिफ्ट करेंगे, उसमें ऐड करेंगे और फिर 3 LG2 को नीचे क्रॉस मल्टीप्लाई करके डिवाइड कर देंगे तो x का आंसर आ जाएगा. जगह नहीं है तो मैं कर नहीं रहा, लेकिन अल्टीमेटली आंसर मेरा ये आएगा. चेक कर सकते हैं. LG 5 upon 3 plus LG2 divided by 3 LG2. The answer is 0.579. सही है? So you can follow both the methods. Sir, can we directly send LG2 to right hand side without multiplying with 3x minus 1? Yes, yes, yes. We can do that as well. सही है. ये भी हो सकता है. सही है, ये भी हो सकता है. मैं यहाँ पर इसको कहाँ करूँ? यहाँ से मैं कंटिन्यूएशन करता हूँ, यहाँ पर ले आता हूँ. ओहो, यहाँ से continuation from here. Yes, we can do like this. 3x minus 1 is less than LG 5 over 3 divided by LG2. And then after this, we will calculate this. We'll send 1 to that side. Whatever answer we are going to get, we are going to divide that answer by 3. LG 5 over 3 divided by LG2 plus 1 divided by 3. So this is also possible. I'm covering a lot of examples, exam type questions, so that when you are actually solving past papers, you don't face difficulties. You have multiple methods popping up in your mind. So I'm covering different methods right now only. सही है, काफी हौच पौच हो गया है, बहुत कुछ कवर कर लिया है. इंशाल्लाह लास्ट एग्जाम्पल की तरफ आ जाते हैं. But this is this is much better. If we split the powers, once we get in this form, then I guess it is more simpler. If you think any other method is more better, you can follow that as well. Just need an acknowledgement if it's clear with all of you. Are you all clear with it? Okay, last example quickly to be covered. 3 power x plus 1 equals 4 power 2x minus 1. It's better to split 3 power x multiplied by 3 is equals to 4 power 2x divided by 4 power 1. Because of 1 minus 1, we can divide. 4 power 2x divided by 4 power 1. Then what we can do is 4. This 4 will be cross multiplied. 4 3 times is 12. And this 3x will be cross multiplied over here. So 3 4 times is 12. 12 is equals to 4 power 2x. So 4 power 2x means 4 power 2 whole power x, which means 16 power x. 16 power x divided by 3 power x. Now, if I would have taken LG or LN on both the sides, then I would have used power law, then I would have simplified. It might have become more difficult or more time consuming. It could, that is also possible, but this is the better approach. 3 power x multiplied by 3, 4 power 2x divided by 4 power 1. Then 4 3 times is 12, and 4 power 2x is 4 power 2 whole power x, which means 16 power x, and 3 power x gets cross multiplied. 16 power x divided by 3 power x equals to 12. And as per another law, 16 power x upon 3 power x is basically 16 upon 3 whole power x is equals to 12. As per law of indices, 16 power x upon 3 power x is basically 16 upon 3 whole power x. Now this is an exponential equation, and this is index form. We can convert into log form. How? Log of answer with a base of 16 upon 3. So log of 12 with a base of 16 upon 3 is equals to x. So log of 12 with the base of 16 divided by 3, the answer is x is going to be 1.4844. And this is rounded off to 1.48. This is going to be your final answer. I think I've made myself clear. Is everyone clear with this? Any confusions? Just let me know. Then Alhamdulillah, we are clear with this, and we have solved all the examples. With that, we have completed the explanation of logarithm. Alhamdulillah. I'm going to upload the past paper questions tomorrow, inshallah. The recording will also be uploaded. The past paper questions will also be uploaded. So inshallah, see you all in the next class, and please attempt the past paper questions as well that I'm going to upload, and make sure that you have written all the notes properly. I'm sure you have already written, but if something is left, just recall all the things that we've studied before moving on to the past papers. Inshallah, the past papers will be a piece of cake for you. Even if there's any problems that you're facing, just bring those queries to me, and inshallah, I'll be more than happy to facilitate you over there. So take care. Have a good day. अपना बहुत सारा ख्याल रखिएगा। अस्सलाम वालेकुम व रहमतुल्लाहि व बरकातहू।